Alright, I might start this video with something a little cheesy, but trust me, you'll be nodding in agreement by the end. I truly believe Kokoro has kickstarted a TTS text-to-speech revolution. We're talking about high-quality TTS that's not just impressive but also lightweight, meaning it's computationally efficient and delivers blazing fast inference times. Imagine turning a 2-minute audio clip into speech in just a couple of seconds. Yes, on Google Colab's T4 machine. And guess what? In this video, I'm breaking it all down for you. I'll show you every single line of code, step by step. Plus, I'm sharing the Google Colab notebook with you, so you can run the entire process without writing a single line of code yourself. Sounds good? Let's dive in. If you're new to Kokoro, I highly recommend checking out my first video where I explain it in great details. Here's the game plan. If you use the Google Colab notebook, I'll link in the description. You won't need to change a thing. But if you're starting from scratch, here's what to do. Step 1. Click File and create a new notebook in your Google Drive. Next, click Runtime, then change Runtime, and select the T4 GPU Easy, right? Now, as you can see, I don't have Google Colab Pro, which means I'm not paying for access to premium GPUs, like the Aeon 100. But guess what? The T4 is more than enough for this project. So, buckle up because I'm about to show you how to unleash the power of Kokoro TTS on Google Colab. Let's get started. Now, here's the deal. I only have access to the T4 GPU, but honestly, that's a win because the T4 is usually available whenever you need it. Just a pro tip, don't leave the GPU running unnecessarily. Once you're done with your task, go ahead and click Runtime, then delete Runtime, and finally, disconnect Runtime. This is not just good practice. It ensures you maximize your GPU runtime availability. Google doesn't explicitly mention how much GPU time you're allotted, but if you keep it running continuously, you might face availability issues later. So, be smart about it. Once you've selected the T4 GPU and enabled it, you're ready to roll. Next, we're going to install Git LFS, large file storage. This is crucial because we'll be cloning the Kokoro repo from Hugging Face, which includes their incredible 82 million parameter model. This repo comes with both the ONNX model and the PyTorch model. Since we're working with an NVIDIA GPU, we're sticking to the PyTorch model for better performance and higher quality. After cloning the repo, navigate into the folder and install a SpeakNG, a speech synthesizing engine specifically designed for Linux. Since Google Colab runs on a Linux environment, this step is absolutely critical for the TTS process to work seamlessly. Now, let's talk libraries. You'll need to install a few key ones, including Phonomizer, Torch, which is usually pre-installed, Transformers, most likely pre-installed as well, SciPy, and Munch. Installing these libraries takes about 35 seconds. Super quick. Once that's done, you're ready to move on to the next step. Now it's time to fetch the model. This is where the magic happens. The voice pack model is the backbone of the TTS system. It's what powers the speech synthesis. To get started, you'll import the necessary modules, build from models, and set up the device with PyTorch. Alright, now let's get into the details of selecting and loading the model. For this demo, we're using the full precision model, which boasts an impressive 82 million parameters. But that's not all. This model comes with a variety of voice options. Here's the breakdown. A stands for American, B for British, F for female, and men for male. You've got voices like AF Bella, AF Sarah, M Adam, and Michael, and so many others to choose from. It's like a buffet of voices. You pick what suits your project best. For this demo, we'll experiment with a few different voices to see how they perform. Once you've picked your favorite, assign it to the voice pack, load it, and move it to the correct device. Since we're working with a GPU, you'll need to move the voice pack to the GPU for optimal performance. Otherwise, it defaults to the CPU, which is slower. Once loaded, you'll see the default voice displayed, F, which is a balanced 50/50 mix of Bella and Sarah. Next, it's time to specify the text for conversion. I've taken this sample text from a fascinating blog post I recently read called AI Agents Capabilities. It's an insightful piece, and I selected a section of it for this demo. To give you an idea, the text we're working with contains 205 words and 1334 characters, pretty manageable for our setup. Now, let's take those 205 words and convert them into an audio clip. That's the goal here, and trust me, the results are going to be impressive. Whether you're creating audiobooks, narrating articles, or experimenting with voiceovers, this setup is going to blow your mind. So, let's jump into the process and see it in action. All right, let's get into the nitty-gritty of handling the text. I've got the text right here, and since it's a multi-line input, I've wrapped it in triple quotes, like an F string or a doc string. This makes it super clean and easy to manage. Now, from Kokoro TTS, we'll import the generate function, which is where the magic happens. You simply specify the voice name and let the system do its thing. But here's a little hack for larger texts. By default, Kokoro TTS doesn't handle big chunks of text very well. So what do? We split the text into smaller, manageable pieces. In this case, we're using the full stop as the delimiter to break the text into smaller chunks. Once we have those chunks, we convert each piece into audio separately and then stitch them back together into one seamless clip. This is where you can experiment a bit. If you're running into errors, try reducing the chunk size further. The smaller the chunks, the more components you'll need to generate and stitch together, but it ensures the process runs smoothly. In my case, I've set up a simple condition. If the chunk length is manageable, proceed. Otherwise, break it down further. It's all about finding that sweet spot for your specific text size. Once you've processed the text and chunked it properly, you're ready to generate the audio. On Google Colab, this is super straightforward. Just use ipython.display to play the audio directly in your notebook. It's as simple as running a few lines of code. So here's what I did. I set up the text, chunked it, and hit generate. As you can see, the system is doing its thing, converting the text into audio. We've got our audio clip ready. Last time, I processed about 1 minute of text, and it worked like a charm. Here's the output, guys. Check it out and let me know what you think.
Put simply, AI agents are artificial intelligence that use tools to accomplish goals. AI agents have the ability to remember across tasks and changing states. They can use one or more AI models to complete tasks, and they can decide when to access internal or external systems.
This process is incredibly versatile. Whether you're narrating blogs, creating audiobooks, or just experimenting with TTS, this workflow delivers high-quality results every time. This is Simplify AI, where we break down complex tech into easy-to-follow steps. If you found this tutorial helpful, make sure to hit that like button and subscribe to the channel for more amazing content like this.